Okay, so this is the R code for week 5. As usual, everything's in my PhD class directory, but if you might want to store the files somewhere else. So set my working directory. We're loading in Excel files, so we're going to require the Excel libraries. And we're going to load in screen.xlsx and just show you what we have here. So this is basically the return for the stock screeners. So this matches with the confidence interval example we had in class, where we have 13 stock screeners and we're trying to get a confidence interval for return. And then we worked out the confidence interval manually. Well, in R, we use the t-test function. Now, with the t-test function, we pass our vector of values, in this case return, and we also pass a confidence level. So we wanted a 90% confidence interval. So we don't pass the alpha, we don't pass 0.1, we pass 0.9. Okay. Now, interesting thing about the t-test function is it does both t-tests and confidence intervals. So if we look at this, it actually includes the results of a hypothesis test for which the true mean is not equal to 0, which we don't want. We just want the confidence interval here, because we're not setting that. And here's the confidence interval. But we can actually get that if you just did, for example, names. You get all the information contained within the output, and one of that is a confidence interval. So we can just get the confidence interval, 7.01 to 14.63, and just check that it actually matches what we did in class and we didn't mess up, so it does. Okay, so the next example, if you remember, we had a hypothesis test, and we had this data, which was emission levels for 10 engines, and we just want to see if this is, in the population, is less than 20 parts per million. So we have our small sample. We assume that we have a normal distributed data, so we can use a small sample. And here we're just going to load in again. We're going to load in emissions, say what's the name of the sheet on the emissions spreadsheet, and we want it as a data frame. Okay, so loading the emissions data. Let's just see what we have. We have like 1, 2, 3, 4, 5, 6. We've basically got 10 items here. We're going to do a t-test. Now, as I said, the t-test function can do two things. That's not always necessarily good thing, because it can be confusing. But here we implemented this as an actual t-test. We set the mu 0, which in this case is 20, and we want to see, we want to test whether the population mean is less than 20. So just going back, is this less than 20? And to do this, the t-test defaults to a two-tailed. So we actually pass the alternative as less. In fact, if you just do ?t.test, here we go, in the help to the right, you can see alternative must be one of two-sided, which is the default greater or less than. We don't have to put two-sided, because if we're looking for two-sided, because that will be the default. So let's just run the function and see what we get. Now, because we've reset the mu 0, we just want to ignore the confidence interval results. They don't make much sense for us. But we returned a t-test, and we returned a p-value. So we're going to, rather than kind of looking up the tables or using the t functions in Excel, what we're going to do is look at the p-value. We're testing using alpha equals 0.01. So, and our p-value of 0.0143 is actually greater than 0.01, so we fail to reject. We could have got the critical t and then compared the t, but the whole point of using computers is that we're not messing around with things like that. So we just directly compare the p-value with the alpha. So let's do a two-tailed example. And this is a bit further on. This is the pipes example from the class. So let's surface pipes. And basically here we have, here we go, some data on surface pipe roughness. This is kind of a quality control example. I want to see if they differ from, the average roughness differs from 2 micrometers. And we're going to use a very strange alpha there. I need to, maybe I'll correct that in the slides. We use alpha equals 0.05. And we just read in the data again from the pipes.xlsx in this basic sheet as a data frame. And we set the roughness. And these are our measurements. So it's a slightly bigger sample size this time. We got to n equals 20. And here we just set, we want to see if it's different from 2. We don't have to select the alternative because 2 sides is default. mu0 is 2, so we test this. Let's just see what we get. And we get a p-value of 0.3225, based on the lowish t statistic. That would be pretty obvious as well. But we see we're testing with alpha equals 0.05, and our p-value is much greater than that. So again, we failed to reject the null hypothesis. We failed to reject H0. So exactly the same as in class and SPSS. Again, we could have just looked this up using the functions in Excel. Sorry, using the functions in R or using a table, but we're just going to go with the p-value. And that's pretty much it.